my name is LeaAnne, as Richard mentioned. We're so excited to be here co-presenting on this, really fun project. So I work at Evergreen, a Canadian nonprofit with a mission to make cities more livable, green, and prosperous. And I just want to acknowledge where I'm calling in from today, which is Toronto, on the traditional homelands of the Wendat, Haudenosaunee, and Anishinaabe Confederacy, which I'm so grateful to be a settler on. And so we've been working on this project, AI for the Resilient City, which is a scalable planning and prediction data visualization tool that will enable municipalities to mitigate climate risks and inform infrastructure policy decisions. And so you might be wondering, why on earth is the Director of Marketing Communications talking to me about AI and ML, which is a pretty valid question. But there's a couple of reasons. One, I do lead some of the digital product development at Evergreen, and so currently working on relaunching our digital hub, which is all about community solutions. It started as a Smart Cities Solution Hub, but we're evolving it to a bunch of other tactics and strategies in the coming months. And so pretty excited to be leading that. And then, I think even Nana touched on this, but just this idea of approaching a project like this as an exercise of design thinking. In that regard, it's not just about the technology and the data, but it's very important to sort of know, how are we defining the problem, who's actually going to use this tool, and how, and it's really about the narrative around this and ultimately the adoption of the insights that are coming out of it. So I've been so lucky to work with people who are actual experts at Gramener and Microsoft. And so I am just going to talk a really quick minute about what Evergreen does to help place this in the Canadian context. Evergreen's been around for 30 years. We've been facilitating change in communities across Canada, issues like climate change, access to nature, and revitalization of public spaces. And our key approach is really about how do we bring different stakeholders to the table that are across different sectors to really tackle this. And so our core belief is that there is not one actor who can actually do this alone. Many of us know Evergreen is known for the brickworks in Toronto, which was once an industrial brick factory and a floodplain. Everyone told us we couldn't build this community center, but it's now a showcase of green design and award-winning public space and a test site for us. So we actually test ideas there and then scale them across the country once we know they work, so that we can make our cities better. So the project we're going to talk about to you today is really through our initiative, Future Cities Canada, which is where we're working with many stakeholders to accelerate innovation. And this is again where the Smart Cities work comes into play, and that we're supporting municipalities directly within this program. You can go to the next slide, Shravan. It's called Community Solutions Network, and it's designed to help communities navigate the Smart Cities landscape. When we're working with municipalities, very often they don't even know where to begin when it comes to adopting some of these solutions, which can be small Smart City solutions or very complex ones. We're obviously talking about one that's more in depth today, but the idea there is building capacity to make sure that they can actually advance those solutions. So, I encourage you to check it out and register. We also do lots of really great events, which we'll be launching some more information on shortly. And I'll pass it over to Shravan just to introduce himself.
Unmute myself. Okay, that took a second to unmute myself. I am Shravan Kumar. I lead the client success practice at a company called Gramener. And who is Gramener? We are a data and AI company who's worked with, we've been in the business for the last decade or so, and we've worked with names from the enterprise sector, you name it, the Ernst & Youngs, the Deloittes, the Dells of the world. And on the other hand, we've also worked with a lot of players in the philanthropy sector, including the Microsoft AI for Earth, which Nana has mentioned as part of her work. We work with organizations like the Bill and Melinda Gates Foundation, World Mosquito Program. We have a good body of work that is known for its impact with the government of India as well. Right now, I'm delivering this session from India, which is where I work from, and Gramener happens to be an Indian origin company, but we have locations. We are located around 5 places around the world. We really, I think what we do really good is to kind of convert the data consumption, address the data consumption gap, which is there's a lot of data, there's a lot of insights that companies are looking at, but how do you make it palatable to the average user, which again, Nana and LeaAnne touched about, but our biggest value comes from bridging that consumption gap. We come in all forms and shape: analytics, consulting, data engineering, statistics, and not last but not least, design consultants. Um, so our idea is to make data and analytics available for the entire world. So that's why our caption goes insights as stories. And we've served, like I said, 120 plus clients world over. Our ultimate vision, if you ask, is to simplify data science for the entire population of the world. That's me, and I'll throw it back over to LeaAnne to introduce the solution itself.
Great. Yeah, so I mean, I think the ultimate goal here is that we're really looking at ensuring that municipalities can identify infrastructure and policy opportunities so that they can take corrective action and begin to design solutions. We released a report last year that speaks to the amount of money that is going to be invested in Canada in infrastructure, which is like 11 trillion to 30 trillion in the next 30 years, I think. So not an insignificant number. And so how can we best use that investment right now, knowing that when we make decisions in policy, the impacts of that takes 5, 10, 20 years. So really, how can we be forward thinking when we are looking at this? You can go to the next slide. And so, we focus a lot on resiliency planning with our municipal work. And so what is, in the toolkit that is at the disposal for municipalities. And, when we think of resilience, it's not just in that sort of shock reaction of, being ready for that moment, but it's also looking further to the future. And so the first climate hazard that we looked at was extreme heat. And so the tool focuses on urban heat island. And we know that what's unique about this tool is that it has planning and prediction in one usable platform, and that's looking at complex data sets, which isn't necessarily always happening. And municipalities are using different tools for different pieces of what they're looking at. So the team we're working with right now at the City of Calgary is pretty excited about what that opportunity provides them. Next, and you can speak to this one.
Yeah, I can speak to this one. So like LeaAnne mentioned, we had to take a completely design thinking angle when we approached the City of Calgary of what is the current digital infrastructure they have in place to mitigate climate change. Do they even have a team that invests their time in foresight or resilience planning, disaster mitigation, so on and so forth? And we happen to find that the City of Calgary itself was quite advanced in terms of using technology to solve these problems. Then we had to take a step back as to what could be the highest impact in terms of highest impact tool in terms of planning their resilient strategy and being in line with their current programs. So what we really found was this is a report. There's a survey report that we found out, which maps all the calamities that the shocks and stresses the city faces on a likelihood score versus a consequence score, right? So what you see on the red circle, the red dot, is the heat waves, which means the likelihood score of a heat wave is pretty high, and it's pretty mid-range in the consequence score. But there is an outlier over here, which is the river flooding. So I don't know how many of you've known. This is something that I came across after getting into the project, but Calgary has a huge river by it's a city by the river. So river flooding is a huge phenomenon, and there was a flood in 2013 which caused huge devastation. Although the consequence is high, the likelihood of a flood in near future is lesser. So we ended up appreciating the fact that the heat waves are something that are happening every year, every summer, and this is a problem that the city didn't have any infrastructure in place to kind of mitigate this, or any kind of foresight planning to make people more comfortable, or mitigate that in the long term to make the city more resilient towards these stresses. Just to put that in perspective, heat waves as a natural phenomenon, they cause a huge 6 factor. By the way, this scale is 0 to 6. A human the consequence on human health and safety of a heat wave is 6, whereas a river flood is 5, right? And that kind of puts that in a perspective how highly impactful or negatively impactful a heat wave could be, and yet it is not attended to, or they don't have enough tools to actually mitigate such a phenomenon. So we found that surprising, and that gave us the opportunity to develop this tool. LeaAnne, you could speak to the current pilot, the overall lay of the land.
Yeah, so we just launched the beta, a couple of months ago, and so we're still sort of working through the questions around onboarding and all the good stuff that goes into that moment. And the tool we built is really for municipal staff, like I said, planners, climate specialists, also just regular like project leads, sort of working with a small group right now, but with the anticipation to grow the people who are actually using the tool on a day-to-day basis. And so the goal of the use case is really to create a baseline of the most impacted areas in the city and then project future levels of UHI. We really focused on going deep with one city to start, and the goal for scaling, which we can, if there's time, we'll talk about it at the end, but the idea that we could, once we have a proof of concept, we could scale it to other cities in Canada to increase impact across the country. UHI is also difficult, I think, use case indicating context with the 4 seasons, as well as the different terrain and climates that are across the country, vary quite a lot. And so next up, I think this is the fun part where Shravan's going to actually dig into the features of the tool and kind of bring in that technical lens.
Sure. Thanks again, LeaAnne. So just on the tool, we've been talking about that was a build-up, but this is the actual core of the application. In its most so to say lamest terms, it is actually a geospatial map basically, which sits on a web framework, and it has multiple views to it, where the typical user can consume insights by interacting with the tool. This also speaks to one of the concepts that Nana mentioned, where the downstream application of an AI or a machine learning algorithm becomes very, very difficult for the average user to take. So this was a step to kind of create an example of how machine learning or AI or these esoteric concepts can be made more democratic in the context of the municipality or the city that is using the government staff or the climate mitigation team that do not necessarily understand too much of technology, and not to inundate them with a lot of lot of technology, a lot of math, and a lot of data. So how can we synthesize those data points and give them a view that they can consume or download and take actions on downstream? So as a result, we arrived at these views, what you call the story mode, the explore mode. We'll dig into that a little bit in a minute, but we wanted to give different modes so that a less informed user can come to a screen and be, consuming insights from there. But at the same time, the more advanced user could go tweak the tool to get more advanced outcomes or insights, right? So let us dive in. The entire tool kind of tells the story of the urban heat islands in the city of Calgary. So when I said the geospatial app, this is a sneak peek of what the web app would look like. It consists of a map and then a lot of bells and whistles to complete the story. What you see in the map is a satellite-based land surface temperature map, which kind of identifies the temperature at a particular point. The point itself being a 50-meter or a 40-meter pixel, and the color denoting the temperature at that particular pixel. So you can identify where those heat pockets are and what is it being caused by. So level by level, we wanted to give the user on what is happening and why, and uh, who is impacted, and then go to the what ifs, right? So how do we do that? uh, so this is the how. We wanted to have a tool that is simple enough for the average user, at the same time specific enough for people to actually make decisions out of it. The UHI at its most basic structure is the map that you see is divided into grids, and every 50 meter you can find a different temperature, which is fantastic, because when you divide an 800 square kilometer worth of area, which is the surface area of Calgary, you get almost 1 million pixels. And identifying temperature at each particular pixel is powerful, because you can then intervene at that particular level and then say, can I have interventions? Can I have gardens? Can I have cooler roofs installed, so on and so forth? What else does the baseline do? We've also tried to amalgamate climate model data, identify trends over a period of time. If a particular pixel is, observing more temperatures or lesser temperatures, so on and so forth, right? Then you also have a particular point of interest, like the airport, like any industry or a building, and one can track the entire trend of temperature in and around that area, so that you can have better planning. The buildings that are being permitted anew, they can also be planned accordingly in conjunction with the data that you have and the policies that you have. So this is really a policy making tool that we wanted to create. And of course, comparing the one area with another, one area over a period of time, and the different layers of or characteristics of that particular piece of land on what is being caused. So this is what it looks like. So like I said, there is pixel level data. You can also have hidden features of the satellite imagery, which is the vegetation index, the building index, so on and so forth. You also have other views like the weather, infrastructure, population, which gives you much more detail. But that does not end there, right? There's no fun if it ends there. But when you really zoom into each and every pixel, you can not only see the variables that are being observed at that particular pixel level, which is how much vegetation is there, is it a barren land, is it road, is it a tarmac, or is it a completely built up skyscraper kind of area. On the right hand side, you can see the particular satellite image that for that particular pixel, or the 50 meter or a 30 meter pixel, and actually quantify the parameter that characterize that particular heat pocket, right? And you can go back in time. You can select a particular pixel or ward. So, for example, the municipality has different wards, right? And each and every block, people who are responsible for that block could only go to that particular block and consume insights, right? Um, then this is the what and where is it happening, identifying where the heat pockets are. But the next level of the tool kind of tells you who and what is impacted, right? So when it comes to what or a big thrust by the governments, at least in Canada, like LeaAnne mentioned, there's a huge investment that is going to happen in infrastructure, and not only developing the new infrastructure, but also making them align to the new policies, which are in line with a more resilient Canada. Also refurbishing or restructuring the existing infrastructure to align with those policies, right? So what kind of development, is it a skyscraper that is contributing to more temperatures in that particular region? Is it the neighborhood characteristics? If there is a park nearby, or if there's a water body like a lake nearby, well, are you observing lesser temperatures so that you can drive policy making decisions by by the government, and say, hey, when you give new licenses for new developments or corridors, this is the kind of vegetation you need to have overall, and at a block level, so on and so forth. Then there is proximity to points of interest again, airport, hospitals, industries. There's a huge industry nearby, the emissions are going to be higher. Is there a building that is emitting more gases because of AC consumptions, and hence there is more dissipated heat, and the ambient temperature, the surface temperature is all high, right? So amalgamating all these data kind of allowed us to take the characteristics of that particular place and then analyze these this causality. Then coming to the people aspect, there's again a huge focus on the vulnerable groups of the population. If there is an older section of the population living in a particular pocket, can you prioritize that area? If there are more infants, can you have a hospital nearby? So although that is the general planning, but if there is a heat pocket or heat island in that particular locality, can you do something about it? Plus, there is a huge focus on the indigenous population by the government, which is also of huge importance. This is where the census data and downsized population data comes into the fore, and allows us to really, at a pocket level, analyze who and what is impacted by the urban heat islands. So think I think there's a problem with the images. Oops. Okay. I'm not sure if I can find. Okay, I was wishing I could show this. I'll pause my screen share and then see if I can get this back. Sorry about this.
Richard, how are we for time check? Just want to check in.
Yeah, Jaisel's running the clock for me at the moment. She was suggesting that we finish at 5 to 6. I'm sure she'll correct me if that's not correct. So that's 7 minutes from now. How's that going to be for time-wise for you? Yeah, I'm getting a thumbs up. Great. Okay. Don't worry about the technical things. It happens to all of us.
Let me reshare my screen and see if this works. I'll get back to the other screen. Doesn't work. So what I really wanted to show is the screen where these are screen grabs from the actual tool which were designed. So what the first screenshot tells you is, do certain properties have more effect on the UHI, and are residents in a particular location being affected by a certain phenomenon, right? The right-hand side, as you see, is the building footprints. This is where we used the AI-generated Microsoft building footprints to actually identify and join that with the city data, which told which building was permitted when and how old are these buildings. So the colors could be, the colors of the buildings could be how old they are, and correlating that with something of a comparison chart, which tells you, hey, a combination of 50% vegetation, a skyscraper, and an old building gives you a UHI or a land surface temperature of this much. Now, can you tweak these parameters and get to a better situation, which makes the people living over there comfortable, more or less comfortable, right? I'll speak to this in a later slide, but I wanted to drive home the point that all these data coming together are really to identify what is being affected and who is being affected, and hence if the government. I'll quickly switch over to my other screen, which had the presentation. I hope the future images work. Going back to the model, the real machine learning model, which was at the center of this entire piece. We wanted to abstract the complexity of the model and give it in a UI or a usable format. Assessing effects of infrastructure on UHI and vice versa. What kind of development, if you can identify what are the building counts are or building height. We also played around with a lot of variables like floor area ratio, which is a policy decision making KPI or metric, which the government tells that the floor area ratio should be 80% or 90%. If it is more than that, your building is illegal, so on and so forth. We also played around with a lot of variables like building site coverage, building block coverage, which really is a representative of how dense or sparse your built up is in the urban areas. So a combination of these variables would have given you a model that would allow the policy making to be taken one direction over another. And it really tells you where should you intervene, and why do all of this, right? So it's a resource intensive process, requires specialist teams, GIS and analytics teams. And one of the points touched by Nana again is that you have to ground truth your findings from different places. You also grapple with choosing the right sites to prioritize, and you also run into these operational issues of missing high priority areas. And this tool is actually supposed to give you that precision and accuracy with which you can actually drive policy making, and also make the right decisions in your investments. Finally, I just wanted to touch upon and drive home the message that this is not a linear process, and it requires multi-departmental collaboration. So it really came down to these 4 broad steps, or 4 or 5 broad steps, which is identifying the data, creating an inventory of the data that you have, and synthesizing all of it, building relationships with the non-technical audience, the people who are making decisions and downstream decision makers, consult and develop with them, identify and operationalize these policy making and interventions at the ground level, and then monitor and improvise based on that. Monitor and improvise is where we are today. So we've developed the entire piece and operationalized it with the city of Calgary. Now they're in the process of identifying those areas where they need to intervene, and we're watching this process for the AI and ML to improve upon the findings on the ground. Now I think I will throw it back to LeaAnne to talk about how we plan to look at the vision, future vision of the tool. Yeah.
Yeah, and I think, I'll sort of probably just wrap up considering our time. But, we're like I said, we're trying to make proof of concept right now, advance it to a couple of other cities within the Evergreen network. And then also look at how can we expand UHI to a broader audience around city builders. And so instead of just being so focused on municipalities, how can we bring in developers or small, medium enterprises who are actually advancing some of the other innovative solutions that cities are working with, so that they can be looking at at data in a more meaningful way. And then, Shravan spoke to flooding as one of the other use cases, but there are lots of other, obviously lots of other climate issues that we could tackle. And then I think, lessons learned is always a critical piece of this. And I think for us right now, it's really thinking about the adoption of the tool and how that will only, move at the speed of trust. And so that's where the complex partnership building is really critical. And just being able to actually describe like what is happening when it comes to machine learning, what are the decisions that we've made, and just being able to showcase that in a way that people can understand. And so I feel like we're probably at time. There's a couple of other interesting slides I know just from Shravan and some other work that they've done, and maybe we can just leave you to explore that in the future.
Thanks, LeaAnne and Shravan, for your talk. And I think this is so much detailed. I think people are now going to relate it, how you can, take the data, make it palatable. What Shravan very rightly mentioned, creating insights from data is what people are now looking at, creating the trend analysis or, the pixel precision that you have shown. Important part is looking at the detailed features of your tool and the successes of it, and how it has enabled to mitigate, the climate change. And I completely relate to what LeaAnne has said, that, if we build it for one of the cities, then, we can scale it up globally and use it for other areas as well. As I know from the background, Shravan, you have been using it for malaria reduction in certain areas as well. So these kind of initiatives, we can imagine how the data can be absorbed, and you can really reach out to people and see what are the risks of climate change and actually build resilient cities with the help of design thinking. As you mentioned, it's going to be a very important part where AI is going to be used, especially talking about explainable AI and responsible AI. But this is going to help developing more and more cities. I'm sure people are going to look at the features that your tool has and see whether they can scale it up or what else can be done from that matter. Thank you. Thanks so much, Shravan and LeaAnne. And I have just one question initially. Let me just go for it. It's from Henry, and it is historic satellite data of temperatures available? If so, would it be possible to produce an analysis of Milton Keynes or any other city over its development and for use with future planning?
Maybe I can take that.
Yep.
So I think, yeah, I'm reading the question. I think this particular model is agnostic to the kind of variables on the ground, which means you do the generic analysis. There is this general part which can be scaled to any city in the world, and there is this proprietary or city specific data which is more customized to that particular city. So barring if someone makes sure that the data availability for a particular city is taken care of, this solution can scale to any given city in the world. And because it's an urban heat island by definition, doing it city-wise makes more sense than do it completely for a nation, for an entire country. but then you will lose out on a lot of specific insights for a particular city. But yeah, the short answer is yes, it can be produced. The analysis, the visualizations can be produced for any given city, and yeah, and made equally impactful.
Great. Thanks, Shravan. I hope this has answered the question for Henry. There's one more question from Rochelle. It is very interesting and informative presentation. Is it possible to select multiple climate risks, for example, UHI and flood risk, to see on one map?
Yeah, I think it's more of a design question. So long as we do the due diligence on the designer or the consulting piece, which is if the problem or the solution that we are trying to address is to have multiple climate risks visualized on the same platform, this will be slightly tweaked and designed accordingly so as to not inundate the user with a lot of data. Yeah, so I think with the right design put in place, I think this can be scaled to other natural calamities also. And we are already doing it. Yeah. So just in addition to that, question or the answer, Gramener is already invested in some flood risking profiling for cities in India. And do visit us if you want on our website, and we'll be happy to walk you through that work as well. And it's all about amalgamating both these works and putting together a single platform.
And there's one last one which I would be taking in from Nicola. I'm interested in your stakeholder consultation process. Can you give us some more information on how you go about building up that trust and make sure the tool is useful for decision making, which is, I think, very crucial for everybody to know. Yeah.
Yeah. LeaAnne, you want to take that?
Sure. Yeah, I mean, I think upfront when we were designing what the deep dive would look like, we looked at a really broad group of stakeholders to start with. So people who, we sort of chose Calgary, but we were looking at lots of other staff at Evergreen who are working with other municipalities across Canada, people from different, with different titles and their jobs, and really sort of being able to define some of those aspects and giving people a voice to share their pain points. And I loved the exercise around like, how are you going to use this tool? What are your pain points? So it really has to be solving a problem for them and not just be, we've had lots of conversations about like, well, this, it can't be just a tool to say we're using AI, it has to actually solve my problem. And so that's why the tool has such a mix of the features that we've landed on. Yeah, and I mean, when you think about building trust, I guess it really is making sure that people have a voice and a place where they can question and not feel like they are asking dumb questions, which I'm notorious for and do often. But just, I think that's what was so great about the Gramener team. They just, answering every question, being able to showcase the thinking. It's a bit high touch at times, but if you're in a municipality and you're going to change a policy or tell the developer they can't build something somewhere, or they have to use certain amount of materials for green design, then you have to be able to back it.
Definitely. I think, LeaAnne, thank you so much to you and Shravan. And this has been really insightful, your urban heat island pilot. I'm sure people will be looking for how this can be extended to build more and more sustainable and resilient cities around the world.